Hey guys, my name's Autumn. I'm gonna apologize in advance. I'm slowly losing my voice. You're gonna have to bear with me for our first discussion. What constitutes scientific knowledge versus pseudoscience? In my opinion, what constitutes scientific knowledge is the fact that the topic being researched is something that's going to be accepted, that's going to change, it's going to have limitations, and it's going to invite criticism. Something of scientific knowledge will have accurate measures with varied results, and also will be peer reviewed. There will be people who are going to review the results that have been obtained. They're going to try and question it. They're going to figure out where the limitations are and how else they're going to be able to research and how else they can improve it. Pseudoscience is something that's going to be based off of typically a fixed idea. It's something that's going to be false and untrue, but the person who believes in the pseudoscience firmly believes that it is. They're not going to want any criticism. Typically with pseudoscience, they believe the results are all encompassing. They're not going to just help one area, they're going to help a bunch of areas. The measures are typically going to be rounded rather than varied, and there's going to be very little support for the pseudoscience. Some examples of pseudoscience, just some common ones you see on a regular basis, are going to be a bunch of weight loss pills or devices saying that you can lose 10 pounds in 5 days. It's just not true. A lot of them are going to be either harmful rather than helpful to somebody, and there's not going to be a whole lot of research behind them. Another just an old school pseudoscience fact is going to be the fact that there was belief that the earth was flat, when we in fact know that it is round, but back in the day people used to believe that it was. Some pseudoscience for our area of psychology would be by Gall. In the case of phrenology, Gall believed that by rubbing the bumps on somebody's head, you could tell their personality, which was in fact not true. It was pseudoscience. But what we did get from Gall, which would be scientific knowledge, is the fact that our brain is where we hold our character, thoughts, and emotions. So there can be parts in pseudoscience that can be true, but you have to be careful on what they are, the beliefs behind them, and what the research is behind it to see if it's true or not. In your opinion, what should be the interaction between science and culture? The interaction between science and culture is very, very important in research. Culture can set the pace for what the trends are at that time. For example, autism is very big right now. Its prevalence is about 1 in 60 in children. So it's a hot topic to research, just because its prevalence has greatly increased in the past couple of years or so. So with that, current research is there was a correlation between vaccines and autism. So that correlation doesn't mean causation, but people still tend to believe that some vaccines can cause autism. But that is just an example of some research trends that are happening right now because of the prevalence of autism in our current society. A caution with the interaction between science and culture is going to be bias awareness. The motivation behind the research, facts that somebody received, information that are not being falsified, because if you hold a certain belief and you're doing research that might go against it, it could unknowingly feed into the research, causing incorrect results that are not going to be valid and are not going to be the correct ones. So it is very, very important for culture and science to have a correlation, but you have to be cautious with it. What criteria would you use to accept something to be scientific fact? I don't like the term scientific fact, just because it's always changing. Just because something is true today, when we get more technological advances and stuff, it could change, or a part of a research can change. But if you're going to say something is a scientific fact, it's because there's experimental evidence to prove it is true, and it has been proven true numerous times to prove validity and reliability. When that happens, and it's happened many, many times by many people, and limitations have been put in place, then something can be considered a scientific fact if you use that term. Like I said, I don't particularly like it just because things change all the time. And one example of a research, only part of it may be true, whereas other parts might not. For example, I mean, it's a scientific fact that we do use our brain to control our thoughts and emotions. It's been proven because there have been fMRI images. There's been many, many studies showing our brain activity and the image scans. So it's a scientific fact. That's where that occurs. Pardon me. So examples such as that, you can say something is a scientific fact. Oh, let's stop it now.